All right, welcome. Today we're going to do a Chapter 5 review. Now, the first thing we need to know is the difference between an observational study and an experiment. In an observational study, we observe the individuals and measure variables of interest, but we don't attempt to influence them. In an experiment, we deliberately impose some treatment on those individuals. So basically, when we are doing our observational study, we're just kind of looking at a set of data. We're looking at surveys. We're looking at something, and we're getting information out of it. In an experiment, we're actually doing something and we're testing to see how what we did affects um, our y variable or our response variable. Now, typically what we're going to do is we're going to sample. Sampling involves taking part of a study in order to gain information about the whole. So we just take 30 students from Irondale instead of surveying everybody. If we decide to serve everybody, it's called a census, where it attempts to contact every single person in that population. Now, there's often a bias that occurs, and a sampling method is biased if it systematically favors certain outcomes. So if it tends to not, maybe if you're doing a survey that is only taken in the morning, um, then it excludes anybody who wouldn't be there during the day, afternoon, or evening. There's 7 types of bias, and some books have more, some books have less. But undercoverage is when a certain group is not covered at the appropriate level. Like, say, if you survey all Americans and there's only one Asian, and Asians make up um, more than 1% of the population. So if non-response, if I send out the survey to 100 people and get back 10 of them, that probably the 10 people who responded are probably very motivated about that issue. So you probably don't get a good idea of what everybody believes. Response bias, if you do something to influence the response of the person taking the survey, that can it influences how they respond to a particular question. That can skew the data. The wording of the questions. If sometimes the wording is so confusing that students or the person responding doesn't know whether they should put in yes or no for how they feel. So you got to make sure the wording of your questions is clear. Voluntary response. If you do a poll on CNN and people get to call in and respond, that is still only getting the people who are very excited about that issue. Size bias, I think that this is kind of a dumb bias. I don't know who would ever do this, but say if you're going to survey every state in the nation and you give Alaska more surveys because they're bigger than, say, Connecticut, um, that would be a size bias. And selection bias, if the group that you're selecting um, isn't what it's supposed to be. Now, there's different ways that we can select. There's a simple random sample, and that is when we take all of the people, line them up, and we give each person a number, and then we randomly choose 5 numbers, and then we match those 5 numbers with uh, with the numbers that we got. The cluster sample is when we put people into groups, and now you number each group, and you randomly select a couple numbers, and and you interview everybody in those groups. A stratified random sample is when you separate people in the beginning between, say, men and women, and then you order the men, you order the women, you give each person a number, and then you pick 5 men and, say, 5 women out of the group using random number table, and that would be a stratified random sample. For instance, if I have a few data points here, well, here are some data points. Let's say each letter represents a person. So if I want to do a simple random sample, I'll number these from 1 to 8, and now I would randomly pick, say, 3 numbers. So you do a random integer on your calculator or on a computer. You pick 3 numbers, and those 3 numbers are going to be your data set. Now, if I do a cluster sample, maybe I will call these ones a cluster, and these ones a cluster, and then I would just randomly pick one number, say I pick these guys, and then I'd give the survey to all of those. Now, in a stratified, I'd have to know more information about these. Say if these people live, these people are all male, then these are female. So you separate them into male and female, and then you give 1, 2, 3, 1, 2, 3, 4, 5. Let's say I want to pick one male, so I randomly choose a number between 1 and 3, and here I pick one female. Now I'm randomly choosing a number between 1 and 5. So that last one was stratified. Going out of control here. There we go. So random digits, sometimes you use a random number table. Those are the numbers 0 through 9. Each entry is independent of each other. The experimental units are the things you're doing the experiment on. Subjects are what we call them, the experimental units, if they're people, and a treatment is the thing that you're doing to those experimental units to test what happens. The explanatory variables in the experiment are often called factors. And then there's different levels of factors, and that's how many values you have for each factors. So maybe you're going to do like light intensity and intensity and fertilizer for your explanatory variables, and you're checking and you want to measure like the length that a plant grows. You might have a few different levels of light intensity, like 5 hours, 8 hours, or 12 hours. And those would be the different levels of this explanatory variable, light intensity. And for fertilizer, maybe we'd have yes and no, whether you're using fertilizer or not. And that's 2 different levels on this factor. Now, control is the first basic principle in designing experiments. You need to have control all of the other elements in the situation, and just so the only thing that's changing between the 2 groups is the one variable that we're testing. The control group is the group that doesn't get the treatment. So if we have everybody in one spot and you randomly pick people to go to the treatment, and then this other one is usually the control. This one is just the people who don't get whatever this treatment is. Maybe you're testing baldness, and you take 50 random bald people, and you select maybe 25 to get this new cream that they put on their head, and then the other 25 are just the control, and they do nothing. So maybe they'll sometimes you can give them a placebo or something, but sometimes they're just doing nothing. Now, the core principles of experimental design is we need to have a control. You need to be able to replicate this experiment many times in order to test to see if your results happen over the long run or if it's just happened just once. And you need to have some sort of randomization in the process and to have impersonal chance to assign experimental units. So a totally randomized design is if you take all the subjects, and the first thing you want to do with the subjects is you want to randomize them. So you randomize them so you have maybe some people going to the treatment, some people going to control, and you could have multiple treatments. Doesn't always have to have one treatment. But then once you're done with this, you want to come back together and compare the results. That is a totally randomized experiment. Sometimes the control, we will do a placebo effect. Well, the placebo effect is the response that people have to the dummy treatment. So if the response that maybe you feel like your headache's getting cured from a pill, but really it's just a sugar pill. So our goal is to make sure things are statistically significant. This isn't that big of a deal because we'll deal with this mostly second semester. But once it's statistically significant, we can show that one thing that maybe caused something else to happen. Here is an example of totally randomized design with 6 groups. You take everybody and you randomly allocate them to the 6 groups, and then they get these treatments, and then you compare the response. This asks how you can assign the students to each groups. So it looks like there's 150 people. So what you could do is give each student a number between 100 and 150, and then randomly choose 25 to go here, 25 distinct numbers to go here, 25 to go here, 25 here, 25 here, and 25 here. Another way you can do it is you can assign, give everybody a number, and the bottom 25 numbers uh, go in group 1, the next 25 numbers go in group 2, and so on, all the way up to group 6. A block design is kind of like stratified for our surveys, but what we do is, or actually that's exactly what it is, but it's just involved in experiments. So there's something that we want to control from the beginning, so we separate people based on that, some factor. For instance, oops, um, I don't know where that page went. Um, Here. Uh, so if here's this is a cancer treatment, and they know men and women respond differently to the cancer treatments, you can block by gender. So you take all your subjects and you block them men and women, and you give them a random assignment to those 3 groups, give them the therapies, and then you compare their survival rates. You do that with each of them. Now with a completely randomized experiment, if we did the same experiment completely randomized, we take all the subjects, and then we randomly assign them to the 3 groups. They get the therapy, and you compare survival. The first method, we can control the variables, and we can look and see how the men react different from the women, um, and we can get better data than if uh, everybody's put into one group and then we separate them out. One type of blocking is called match pairs, and this is when we're blocking with just 2 people in each block. Uh, and there's a couple different types of this. There's match pairs where they have a before and after, um, and each person gets both treatments in a random order. I don't know why I did that one first. And then there's another one where you match pairs where you have 2 subjects that are very similar. So maybe we'll take a girl who weighs 140 pounds and is about 5'8". We'll find another girl that looks exactly like that, and then we run them through a weight training program or something and see what the results are. Um, and the other girl doesn't get the weight training program and see what her results are, and then you can compare them. So you're taking 2 people that are very similar, you're doing an experiment, and you compare those 2 people in the end. A double-blind experiment is when neither the subject or the person who's administering the drugs, typically in a medical study, um, would know whether the person's receiving the treatment or whether it's the placebo. When would it be a good idea to do double-blind experiments? In medical studies. Now, in medical studies, you have to make sure that students or the people and the doctors don't know what the drug is. Sometimes it's hard to do, but but uh, like you have to make sure that the person taking it it's not clear uh, whether they're taking the sugar pill or the actual pill. And that's it for that.